Welcome to our physics class. We are continuing chapter 13 sound, and today we will learn more about pitch. In the previous classes we have learned about the two characteristics of sound, that is loudness and pitch. Loudness we have learned it depends upon the amplitude of a vibrating body. We have also learned about the factors affecting loudness. We have also learned about pitch. As you know that pitch depends upon the frequency of a vibrating body. For example, if I draw a wave like this, you can see the difference between the two types of waves. In this case, we can see that the vibrating body is moving very fast and making many vibrations per second. But in the second case, you can observe that the number of vibrations are less, and so the frequency of the vibrating body is less. Okay? As we have done in previous classes, the frequency means the number of vibrations produced by a vibrating body in 1 second. And the higher the frequency is, the more the pitch of the sound will be. Pitch is directly proportional to the frequency of a vibrating body. This we have already done. Now today we will see what are the other factors apart from frequency on which the pitch of a sound depends. Okay? Let us quickly recall. Pitch is dependent upon the frequency of a vibrating body. What is frequency? Frequency is the number of vibrations produced by a vibrating body in 1 second. Okay? Now we will see what are the factors on which the pitch of a sound depends. Right? For example, you take a cap, the cap of a pen, and now you blow air into it. Right? If you keep on changing the direction, the sound produced will also differ. Why? The pitch is different. Why is it so? It is because the air molecules are producing sound there. So that is because of the vibrating air column. Another example you take is, you take a steel, same types of steel glasses, fill them up with various quantities of water. In the first case, say half filled of water, like this. You take a glass, fill it half with water. Second glass you fill 1/4 with water. Third glass you fill 3/4 with water. Take a stick or a steel spoon and try to strike it. In the first case, a different sound will come. In the second case, different sound. And in the third case, also a different sound will come. But if you observe carefully, the sound in the first case will be very much sharper as compared to the second and the third case. So what is different in these three cases? The amount of air present in the glass. Right? And the amount of air that is present in the glass is called the air column. So first factor on which the pitch of a sound depends is the length of the air column. Air column is nothing but the amount of air filled inside a vibrating body. Right? I hope you understood. The air column is the length of the air inside the vessel. It can be a glass, it can be a bowl. You must have seen in the olden days that Ch-13 used to be played, where the various kinds of balls were arranged in a semicircle and the person used to strike it using a stick. The same way as we have the steel glasses filled with different quantities of water. In this also, because the air column is different pitch of sound is produced. So the first factor on which the pitch of a sound depends is the length of the air column. This is the second. First is the frequency. Frequency of a vibrating body. Second is the length of the air column. And the third factor on which the pitch depends is the length or thickness of a string. Okay? For example, you take a rubber band. Okay? You take a rubber band and tie it on a box. Simple box like this you take and tie a string around it. Say a rubber band. Now what do? You take 2-3 kinds of rubber bands. One is thick, the other is less thick, and the last one is very thin. What do? You strike those rubber bands. They all will produce sound, but what you will observe is if the thickness is more, the sound is low pitch. Right? The sound produces high pitch if the thickness is less. So depending upon the thickness of the rubber band, the sound produced was of high pitch or low pitch. Is it clear? Same goes for the length. Second experiment also you do the same thing. You take a box, again tie 2 rubber bands around it. Now place a pencil in between. What happens if you place what will happen? The sound will be of high pitch. So if the length is less, the pitch is more. Length of the string produces also affects the pitch of the sound. If the length is less, what will happen? The sound will be high pitch. Okay, if the length is more, the sound will be of low pitch. Then the thickness of a string. If the string is of a higher thickness, the sound produced will be of a lower pitch. But if the thickness is less, the string goes on being thinner, the pitch of the sound also goes on becoming more. Okay, so these are the two factors on which the pitch of a sound depends. First is the length of the air column. You must have observed the flute players or Shehnai players. They also keep on moving their fingers on the holes. So what are they doing? They are increasing or decreasing the length of the air column. And as it increases or decreases, like in mouth organs also, the length of the air column increase or decrease, different kinds of sounds can be produced. The sharpness or shrillness differ, and that is what is pitch. Second factor on which it depends is the length and thickness of the strings. If in case it is a string instrument, you must have seen a guitar or a sitar player. What do? They have the knobs in between. They keep on using those knobs to tighten the string or to reduce the length or increase the length of the string. By doing that, we can increase or decrease the pitch of the sound. Right? This is how, according to these two factors, the pitch varies. Obviously, it depends upon the frequency. Pitch is directly proportional to the frequency of a vibrating body. Then it is directly proportional to the length of the air column. If the length of the air column increases, the pitch of the sound also increases. Okay? But it is inversely proportional to the length and thickness of the strings. If the length is more, the pitch is less. Right? So in the first two cases, pitch is directly proportional to the frequency and the length of the air column. But it is inversely proportional to the length or thickness of the string. If the length is more, pitch will be less. If the thickness is more, the pitch will be less. I hope you understood. I will show you some experiments also to demonstrate these two factors, how these two factors determine the pitch of a sound. Thank you. Okay, children. So this is the first experiment where we will prove that the pitch of the sound is inversely proportional to the length of the string. Take a box and tie a rubber band around it. Take two pens such that there is a fixed length of string in between them. Plug the string, you will get to hear a high pitch sound. Okay, as the length is less, you keep on increasing the length and keep on plucking the thread or the string, you will get to hear a sound of a lower pitch. As the length of the string or the rubber band is increased, what happens? The sound keeps on becoming low in pitch. Okay, this is because the low frequency sound is produced as the length of the wire is increased. So the pitch of the sound is inversely proportional to the length of the string. As you keep on increasing the length, the pitch also keeps on becoming lower and lower. It keeps on decreasing. Okay, this is the first factor on which the pitch of a sound depends. Okay, children, so we will learn about the second factor on which the pitch of a sound depends, and that is the length of the air column. We are having 6 glasses here and we are filling different amounts of water in them. Now we are making a like jal tarang of ours, right? It is our own very jal tarang. What will we do? We will have different amounts of water in every glass, and the space which is empty is actually filled with air, and this is called the air column. The length of the air column is the space available for the air. Okay, for example, the glass is half filled with water, so the other half which seems empty is the air column. So if the length of the air column is less, the pitch of the sound will be higher. Now you take a steel spoon and start striking the glasses. You will get to hear different sounds. Why is this? The difference in the sound is there? It is because the length of the air column is different. Okay, so if the length of the air column is less, the pitch is higher. Okay, children, so what we have learned in today's class is all about how is the pitch of a sound related to the frequency of a vibrating body. What is the frequency? The frequency is how often or how many times a vibrating body vibrates in 1 second, or the number of vibrations or waves produced by a vibrating body in 1 second. Okay, the higher the frequency is, the higher the pitch of a sound is. And what is pitch? The sharpness of a sound. Okay, you can see the two waves in this case. Which one is making more number of vibrations? The first one. So it is a high pitch sound. Okay, like this. In this case, the second one, The second wave is making many vibrations per second as compared to the first one, and so it is a high pitch sound as compared to the first one. First one is a low pitch sound as less number of vibrations are there, and so it is of low frequency. The second one is having a number of vibrations in 1 second, so it has a high frequency and a high pitch. Okay, now you can see a drum produces a low pitch sound or a dull sound as compared to a whistle or a flute, where the vibrations are more, and so it is a high pitch sound. High frequency vibrations result in a high pitch sound. What are the factors on which the pitch of a sound depends? First one is the length or the thickness of a string. If the length is more, the pitch will be less. Okay, so shorter length of a string produces a high pitch sound. Like you have seen in sitars or guitars, the length is adjustable, right? The length of the string we can adjust. If the length is lesser, the shorter length of the string will produce a high pitched note in case of a sitar or a guitar. Same goes for the thickness. If the thickness is more, the pitch is less. Now, right? For example, a thicker say string or a rubber band if you use will produce a low pitch sound as compared to a thinner one. If you use a thinner rubber band, it will produce a high pitch sound. Okay, and the string should also be taut. You must have seen the guitar and the sitar players, they tighten their strings so that they produce a high pitch note. Okay, then the second factor that we have learned just now is that the length of the air column. If the length of the air column is less, that means a small space is available for the air column, then a high pitch sound is produced. If the air column increases, then what happens? It becomes a low pitch sound. Like we saw in the Jal Tarang experiment also, the lesser the amount of air filled in a vessel, the higher pitch the sound will be. Okay, so this is what we have learned in today's class. I hope you have understood it well. Take care of yourself, stay safe, stay healthy.